We are going to be continuing on with probability, and today is actually our last day that we're going to be covering that we have instruction in probability. Today is the last day of instruction in probability. So we have 1.6, this is the assignment that is due today, and it's just going to be a review. This is probability review. Cool. All right, so we're going to be doing, so I just went to this, I basically went into Google, and from Google I typed in probability review, and I ended up getting this quiz that has a certain amount of questions. I don't know how many, but we are going to figure out how to do these to have a deeper understanding of probability for our test. So I'm going to go ahead and do a screenshot of this and import it into, it's way close. This is our first, I'm going to chop something off. Well, now we have all this notation. We have all this notation that we have to, it says, suppose A and B are two events. Well, what is A and B? We don't know, but it doesn't matter. It could be flipping a coin. It could be whether somebody's wearing a hat, how many students are wearing hats, or how many freshmen we have in the class. It doesn't matter what the events are. There are two events. How are these events related? Well, it says, given that, how do we read this? What does that say? Yeah, probability of A and B is 2/3. And then it says here probability of A is 9/3, and then I have to find this. What are they asking here? What does that mean? Yeah, this is a conditional statement. The probability of B given A. I already know A happened. Let's say A is boys and B is glasses. Then I want to know the probability that I randomly select a boy that is wearing glasses. That's what that means. If from my group, I randomly select a boy that is wearing glasses. What kind of tool do you think it might be helpful to use to help us organize this information? We talked about some important tools in this class. What tool do you think would help us organize this information? This should give us a huge hint on what tool to use. Starts with a V. Yeah, a Venn diagram. A Venn diagram has an intersection. Isn't this an intersection? A and B, isn't that the intersection? So let's use a Venn diagram. I think that's a great tool. So here are my two events. We have one event that is event A, and we have event B. And then we have, what is this called? This box that goes all the way around it. What do they call this? Starts with a U. What is it? Yeah, it's the universal set. This is everybody that was in this particular study. I don't know what study this is because I don't know what A and B are. Maybe it's all the students in Mr. Hall's class. So what goes here, right here? Which is what? It's 2/3, which is what? 0.6666666 forever and ever and ever. So I'm just going to write that down here. I have 2/3. 2/3. All right. Now over here it says probability of A. So that's 9/13. Does that look right to you? Is that okay? Yes, no, maybe so? No, why not? Yeah, all of this has to be 9/13, right? So that doesn't tell me 9/13. That tells me 9/13 plus 2/3. So that can't be right. So let's go backward on that one. That can't be right. So let's change that. How do we figure out what goes in here? How do we figure out what goes here?
Or would you subtract?
Which one do you think?
At least
It's subtract, yeah, because we're going backward, right? So I know that something, shoot. I know that something plus 2/3 gives me 9. That's not plus. I know something plus 2/3 gives me 9/13. Right, Grace? Does that make sense? Okay, so all of this is 9/13. So if I want to figure out what goes in this box, then we use inverse operations. I'm going to subtract the 2/3. What's the rule when we subtract fractions? Don't we have to have a common denominator? When we subtract fractions, we have to have a common denominator, right? If I had something like this, I have, if I had something like this and I want to add that to this, let's do some, right? Let's make sure we understand fractions. So after a party, there's this much pizza left. Well, how much pizza is that? Well, I don't know. So what I'm going to do, this is 1/3. Oops, wrong tool again. Shoot. This is 1/3 and this is 1/4. And so what I'm going to do is I'm going to divide it all up into something that where both of them have been divided into the same share of slices. So I'm going to, what if I go like this? Do those now have the same number of slices? No. How can I divide this so we have the same number of slices? What if I divide this like this? Are those the same number of slices?
Yes.
Okay, so how many slices did I divide the whole pie into? 12. And so now we just count. So we have 12 in the denominator. How many of those slices do we have? We have 4 over here. And how many over here? We have 3 over there. So together we have how many of those slices of 12? Would that be 7, 7/12? How do we do that algebraically? Yeah, so how do we make this 12 over here? Yeah, we're multiplying by 1. And the cool thing about multiplying by 1 is it doesn't change the quantity. If I multiply, so 1 times 5 is 5, 1 times 100 is 100, 1 times 1/2 is 1/2. The cool thing about multiplying by 1 is we don't change the quantity at all. We are not changing the quantity at all. And the quantity stays the same. So I'm going to multiply by 1 in the form of 4/4. Isn't that 1? Okay, so if I multiply those, does that give me 4/12? So what do I multiply here? I'm not multiplying by 3 because it changes the quantity. I know what you mean, Grace, but I want to make sure that we understand what's really happening. I'm not multiplying by 3. I'm multiplying by 1. I'm multiplying by 1 in the form of what? 3/3. Yep. So that gives me 3/12. And now what? What do I do now? Add both of them, the numerator and denominator? Only the numerator. So that gives me my 7/12, the same as what I got over here with my picture. So we get this 7/12. All right, so we're going to do, that was just a sidebar, right? I try to wrap our heads around this idea. So let's do that over here. When we subtract these, what do I need? If I subtract fractions? Common denominator. So I'm going to multiply by 1 in the form of, how about 3/3? And then I'm going to multiply by 1 in the form of what down here? 13 thirds. And so that's going to give me 9 thirds. Does everybody know the trick with your multiplying 9 with our hands? When I was your age, 9s were always difficult for me. And so I learned this trick and I just thought it was really cool. And this only works with 9 times tables. This only works with 9 times tables. When we're multiplying 9 times 3, I'm going to put down the third finger. 1, 2, 3. Then I'm going to count how many fingers on the right side. Is that left for you? Left side. And then count the number of fingers on the right side. How many fingers on the left side? 2. How many on the other side? 27. So the answer, so 9 times 3 is 27. That only works with 9 times tables. I do want to move this. I think that this is crowding things, and I don't want, that was more of just an example, and I don't want us to get confused by that example. It was just more of trying to understand why it was that we add, or that we have to have a common denominator. So I'm going to get rid of all of that. That was just an example. So 9 times 3, what's 9 times 3? Right, so that's going to give me, so I have 27 and then 13 thirds. About 39. Does that look right to you? Okay, certainly you can certainly use a calculator for this if you'd prefer. And then down here, what does that become? Negative what? Negative 26 over 39. Okay, now what do we do? Do we subtract the numerators and denominators? Just the numerators. If I subtract the numerators, what do I get? If I subtract the numerators, what do I get? Tavita, put it away, please. If I subtract the numerators, Olivia Halliday, what do I get? What's a numerator? Yeah, it's the top number. This is the numerator, and this is the denominator. Denominator down, down, denominator, numerator. I don't know how to remember that. Just numerator and denominator. Yeah, we're going to subtract the numerators. Ms. Halliday, if I subtract the numerators, what do I get? Yeah, I'm getting 1. So I have 1/39. 1/39 goes here. 1/39 goes there. So did I answer my question? Is that what I wanted to answer? Is that what I wanted to answer? It says here, find this. What does that say? Probability of B given A. So I know that A happens. I know A happens, so I already know this part here, right? I already know A happened. And then what's the probability that B happened? How do we calculate probability? So we're looking at the gosh darn it. We're looking at the probability of A and B over the probability of B. Is that how you understand it? Oh, sorry, probability of A. Do you agree that this is the same thing as this? We're taking this piece here divided by this piece here. Maybe I should use a different color. Does that make sense? That's our conditional probability? Does that make sense or not? So what is the probability of A and B? Yeah, it gives us the answer right there. It's 2/3. It gives us 2/3. And then we have the probability of A, which is, I'm sorry, what? Probability of A is not what, 9/13. So we didn't even have to do all that math. We didn't even have to do all this math to find that. Huh. We went off on a tangent. We figured something out that we didn't need. All right. When we divide by fractions, here's a tip. Did we not watch that video in this class? No. Well, that's just embarrassing. When I have, this is super important. When I have, if I have 15 divided by 5, what that means is how many 5s, that doesn't look like many, how many 5s in 15? Would you agree that that's what it means? What's the answer? 3. The answer is 3. All right, so we could actually literally write it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. How many groups of 5 are there? I have 1, 2, 3, 4, 5. Is that one? And then 1, 2, 3, 4, 5. Here's another one. And then here's my other one right here. So 1, 2, 3, 4, 5. Yeah. So we have 3. We have 3 groups. What does it mean if I have 1/2 divided by 1/4? How many? Yeah, how many 1/4 in 1/2? So I have a half a pizza pie here. And I want to know how many 1/4 there are. There's 2. There's one here and one here. So there's 2. The answer is 2. How do we get that algebraically? When we divide by fractions, here's a tip. Keep the first fraction the same. Change division to multiplication, and flip the second fraction to get 4/1. And now we multiply to get 4/2, which is 2. When we divide by fractions, here's a tip. Why does your voice get deeper when you sing it? And the answer is, I don't know. I don't know. It's just, I guess it's just fun to sing it that way. I'm surprised we haven't talked about this. This is a super important idea in probability. Now, this song, I think it was designed for, I'm guessing, 4th graders, but I think it's helpful. I show this in my calculus class. I show it in my secondary math 3 class. If you have me again next year, you're going to see it. If you had me last year, I actually got secondary math 1. I didn't really teach secondary math 1 last year. I did too. I substituted for Tasha Myers for a couple of months. So I may have some of you from that class, but I didn't teach it for the entire year. All right, so keep, change, flip, keep, change, flip. When we divide by fractions, here's a tip. Keep, change, flip. Shelby, did you see this already in my class? Yeah, that was 2 years ago, huh? So yeah, that was a long time ago. You do remember? Awesome. It's an improper fraction, so we're not through. Divide 6 by 2, and the portion is 3. Keep, change, flip, it's all they need to divide by a fraction. Is a tip. Keep, change, flip. To divide by a fraction is a tip. Keep, change,
understand 5 plus 1 is 5. It's an improper fraction, so you need to divide. 10 divided by 5 equals 2. We divide by fractions, this is what we do. To divide by a fraction is a test. Keep change split. To divide by a fraction is a test. Keep change split. Keep change split. Keep change split makes sense to work magically, but it can't be explained mathematically. With the number 10, we can divide by 2 and happily divide in each group. Or we can find that 5 through a different path by multiplying 10 by 2 once to 1 half. It's the trick that never fails, called keep change split. It's real mathematics, so use this trick. We understand with these are problems we love, because we know the measure means has how many solve. Let's explore that thought. How many groups of 4 does 1 half got? 2 fourths fit into 1 half perfectly, and we found the quotient mentally. To divide by a fraction is a test. Keep change split. To divide by a fraction is a test. Keep change split. To divide by a fraction is a test. Keep change split. To divide by a fraction is a test. Keep change split. Visit numberup.com for exclusive content, lesson materials, and more.
Okay. All right, so how do we do this problem? We have 1.5. Oh, actually, that's not even the problem we were working on. Well, let's go back over here. How do we wrap our heads around what to do with this problem right here to figure out the answer for this? Yep, when we divide by fractions, here's a tip. We're going to keep the top one the same. We have 2/3 change. We're changing from division to multiplication, and then we flip the other fraction to get 13/9. Now what? Yeah, multiply the numerators to get a new numerator answer, 26, and then multiply the denominators to get a new denominator answer, 9 times 3. What's the 9 times table trick? Yeah, we'll put down the third finger, 1, 2, 3, it's 27. So I get 27. 27. All right. We did a lot of math for one problem, but we did some stuff we didn't need to do. So if I look back over here at, where is it? I don't even know where it is. Did I close it? Oh, there it is. All right. So what's the answer? A, B, C, or D? Louder? Yeah, we ended up with B. We got 26 out of 27. That has to be B right there. I don't know if is it going to let me even select it? My word. Oh, it shows us how to do it. Huh, cool. That's a cool website. It doesn't let me, oh, there we go. I don't know. Okay, let's move on to the next one. It says, Victoria either takes the bus to school or she misses it. There's 2 different choices. This is binary. She either takes this, oh no, I'm sorry. It looks like she misses it, then she walks. So she either takes the school bus or walks, right? There's 2 choices. The probability that she catches the bus on, actually what I'm going to do is I'm going to copy this. This is good probability. Some good probability stuffs. Okay, so the first one. So there are 2 different choices. So Victoria either takes the bus or she walks. 2 different choices. If there's only 2 different choices, what tool do you think would be a good model to use in this case? A Venn diagram. We could use a Venn diagram, and I don't know. Is there an intersection for walking or taking the bus? No. So if we don't have an intersection, then this is probably going to be mutually exclusive, or we could use a different method. What's another method where it branches off to 2 different choices? Yeah, let's try to use the tree diagram for this one. I think the tree diagram would be a good choice. So we either have the bus or we walk. Now it says here that the probability that she catches the bus on any given day is 0.4. That's the probability. If the probability of catching the bus is 0.6, what's the probability that she walks? It's what? So remember, there's just two choices, right? There's two choices. Either she takes the bus or she walks. Those are the only choices. So because those are the only choices, we can figure out, if we know what the probability is of riding the bus, then we should be able to figure out the probability of walking. What is the probability that she walks? Yeah, it's 0.6. So that this adds up to 100%, right? Because there's only two choices. So that better be 100. All right, so actually I don't want to erase that part there. And what else do we have? If she catches the bus, the probability that she'll get to school on time is 0.8. Oh, we have another branch. What is the other branch going on here? Yeah, on time or not. It's on time or not. So if she catches the bus, the probability she will get to school on time is 0.8. So 0.8 is, bless you, if she takes the bus, what's the probability she will be on time? And that would be up here is 0.8. What does that mean this has to be then? Yeah, that she's not going to be on time would be 0.2. All right, now it says if she, okay, but if she misses the bus and has to walk, the probability of being on time drops to 0.6. So we have on time and not on time. This is 0.6. What does this have to be then? 0.4? So we have, this is what I want to do. I don't care about the question yet. I really want to talk about what is called it's a probability distribution. The probability distribution of this problem, if I take the bus and I'm on time, actually, let's see let's work out the probability that she catches the bus and is on time for school. Right, so the first one says work out the probability that she catches the bus and is on time on a given day. So what's the probability that she does this branch here? How do we figure that out? What's the probability that she catches the bus and she's on time? When we have, are these events dependent or independent? They're dependent. They're dependent. Independent. They're independent. Catching the bus and being on time, these are two different things that happen. So what do I do if they're independent? When I flip a coin, don't I figure them out individually and then how do I put them together? If I flip a coin twice, what's the probability of getting heads, heads? How do I figure that out? We figure them out separately and then we multiply. So how would we figure out these two events, the probability of both of those events? We do what? We already know what the probability of each event is separately. Now what do? We multiply. Yeah, we multiply. So that would give us 0.4 times 0.8, and that's going to give me what the probability of both of those events happening. 0.4 times 0.8 gives me 0.32. In fact, we should be able to calculate all of these. What's the probability of catching the bus and not being on time? How do we calculate that? Yeah, I get 0.4 times 0.2, which is going to give me 0.4 times 0.2 gives me 0.08. What's the probability I walk and I'm on time? How do I figure that out? Multiply both of those. I have 0.6 times 0.6. I multiply those together, 0.6 times 0.6, and that gives me 0.36. And then what's the probability that I walk and I'm not on time? How do I calculate that? Yeah, that gives us, I just saved it, I didn't mean to. It's gonna have to wait, there we go. So that's gonna give me 0.6 times 0.4. That gives me 0.6 times 0.4 gives me 0.24. What do you think is going to happen if I add all of these up? What do you think all of these would give me? What number? Oops. It should, yeah, because there's not another choice. Those are the only choices there are. Those are the only choices. In fact, I'm going to do it in my calculator. 0.32 plus 0.08 plus 0.36 plus 0.24, and I'm getting 1, which is 100%. Because those are the only things. Either I take the bus or I walk. I'm either on time or I'm not on time. This is called the probability distribution. Probability distribution. Okay. I just sort of lost it at the end. Okay, so let's move on. Did we answer the rest of the questions? Okay, so work out the probability that she is on time for school on a given day, whether or not she catches the bus. All I want to know, it doesn't matter whether she catches the bus or not. I just want to know whether she's on time. What's the probability she's on time? Which of these branches means she's on time? So that's going to give, so this branch here and this branch here. So what are those together? 68. Yeah, the probability that she's on time is 68. We add those together. So that would give us 68. Please, if you want, if I'm going too fast or my explanation doesn't make sense, then please correct me. But this should be 68%. Probability of being on time and catching the bus. Did we figure that out? It was 32, right? On time and catching the bus was 32%. Going to move over here. That was 32%. What's the next question? The next question says, work out the probability that she's on time for school on a given day, whether or not she catches the bus. Oh, I just, what did I mess up? Oh, this goes here and this goes here. Okay, let's look at the next one. Hence, the word hence is always a tricky word. Hence means, look at our previous answer. Hence, find the probability that she will be late for school on a given day. What's the probability that she is late on a given day? Well, hence means it wants us to use this answer. We could certainly go back over here and figure out this plus that, right? Right? We could have just figured out when we're going to be late and add those together. But it's using the word hence, which means use the previous answer to figure it out. What would my answer be then if I have to use the previous answer? What's the probability I'm going to be late? If the probability I'm on time is 68, what's the probability I'm going to be late? What is it? How did you get 32? Yeah, so we have 100%, Olivia? Yes, we have 100% minus the 68%. That's going to give us 32% probability that you're going to be late. If we added the two branches, would that also give us 32? We add that, yeah, it gives us 32. Nice, cool. So there's two different, that's the cool thing about math. We have all these rules, but we have lots of different ways to do the same problem. All right, let's move on to another one. I actually haven't done these problems before. I just last night I thought, what can we do as a review? And then I looked it up and I found it and I thought, okay, let's do this. What does this say down here? Louder? Yeah, this is a conditional statement. This is the probability of B given A. Think of it as a fraction. Rotate it clockwise and we have a B over A. So I'm trying to figure out the probability. I know that, what do I know has happened? The conditional probability says what has happened for sure. A, right? We know that A has happened. We know that that has happened. So the other stuff doesn't matter. We ignore it. So I'm trying to figure out the probability of B given A. So what would my fraction be? How do we calculate probability? Number of ways it can happen out of the total number of outcomes. B given A is the probability. Gosh darn it. How many times is that? Like 5 times now? I've done that. Okay, so I have the probability of A and B. We're looking at this value here, knowing that this has already happened. Right? Would you agree that that's the same thing as this? What's the probability? So this is how it happened, or this is the number of ways it can happen out of the total number of outcomes. So what goes in my numerator? So what is the denominator is what? 5/10. Okay. Yeah. So you just added both of these. I agree with you. It's 5/10. 5/10 or 1/2, right? And what goes in the numerator? What goes in the numerator? Yeah. So this divided by this. Yep. 2/10. When we divide by fractions, here's a tip. Keep, change, flip. So I'm going to keep change. What do I keep? 2/10. What do I change? Division to multiplication. What do I flip? 5/10 to 10/5. All right. So when we multiply, we get what? 20/50. Have you ever heard of cross simplification? Is there a way we can simplify this before we multiply? Don't get this confused with cross multiplication. We can certainly do that. We could go 20/50 and then simplify. Or this is called cross simplification. Okay. Don't we have, well, isn't 10 divided by 10, isn't that just 1? This is called cross simplification. So really we just have 2/5. Yep. We have 2/5. 2/5 is our answer for this question. What's the probability of B given A? Well, it's 2/5. So there's a lot of cool things that are coming together for today. I'm actually glad that we're using. In fact, this is probably the most tricky. A lot of students look at it and say, I'm not sure what that means, Mr. Hall. What does it mean? And it means given. It's given. We already know A happened. We already know that this happened. So what's the probability of B happening? Well, this is the only way. If A happened, this is the only way B can happen. So it's going to be that value over the total value here. Okay, so let's move on. Let's do that one. What was the answer then? Did we figure it out? What is it? 2/5 right here. See? It doesn't let me select it. Wah. All right, let's look at the next one. That one looks tricky. Suppose A and B are 2 events. We don't know what those events are. It says given that Probability of A is 52%, and it's given that the probability of B and A equals 0.75. And I want to find, what does that say? Find what? What does this say? What do I have to find? Probability of A and B. And if I click on this, it'll show me the answer, but I don't want them to show me the answer. I want to try to figure this out myself. So what tool should we use here? I think it's the question that it's asking is the really telling part of what tool I should use. What tool? I have an intersection. So what tool? What does that suggest? Using a Venn diagram. If I have an intersection, I really think we could use a two-way frequency table, but I really think that the Venn diagram is the better choice in this particular case because of that intersection. So then we have our universal set. Here's our universal. I don't know what A and B are. Actually, that's pretty cool. I don't know what A and B are, but I'll just label this anyway. This is my A value. This is my B value. And I know that A is 52%, so I'll write 0.52. Is that okay? Is that okay or not? No, all of this is 52. That means this plus this is 52. I can't do that. That's cheating. So how do I figure that out then? Well, I guess we need to figure out what this means here. Yeah, that means that I know A has happened. I know A has happened. All of this has happened. What's the probability then that this happened? So we're going to write our equation of, we're going to say the probability of A and B over the probability of A. And that has to equal, that is the same thing as the probability of B given A. And so what is that? Okay, so I know the denominator, but I also know what all of this equals, right? What does all of this equal? Yeah, it tells us right here, 75%. So I'm going to say that all of this equals 75%. And then, Grace, you were saying that I know something already here. What was it? I know the denominator, right? So I know the probability of A and B over the denominator of 0.52. And I'm trying to figure out the probability of A and B. So I'm trying to isolate this as my variable. How do I do that? How do I figure out that using this equation? What do I do to isolate this probability of A and B? Yeah, multiply both sides by 0.52, right? If I multiply both sides by 0.52, 0.52 divided by 0.52 is 1. Do the same thing over here. And so that gives me the probability of A and B equals, well, what? 0.75 times 0.52. I'm getting 0.39. Question is that a choice? Is that a choice? Well, does it give us a choice? Well, that's the answer then. Is that confusing? Sam, a little bit confusing? Or sorry, Ryan? So it really comes down to getting lots of repetition. Now, if you like, I actually don't think the test is this difficult. The test that you're going to take is not this difficult, but this is good practice, especially for those who want to take AP Statistics. AP Statistics is a class that we offer at Highland High School, which gives you the opportunity to get college credit. You have to pass a test at the end of the year in May. After this class, you are ready to take AP Statistics if you would like. So next year you can take AP Statistics, and or secondary math 3, both of those would be choices. I believe statistics would count as your third math, but I would challenge you to continue to take math all the way through your senior year. So you could take secondary math 3 next year, and you could take statistics if you wanted. But this is, if you like this kind of math, then you should take statistics. All right, let's move on. Let's look at another one. Oops, I keep on opening that one and I mean to click this one. Let's look at the next one. Yeah, if you guys want this website, if you like this, you can watch the video on how to do the problems. If you like it and you want to do the rest, I don't think we're going to be able to finish in class. So you could email me and say, Mr. Hall, can you send me that website? I'd be glad to send it to you. In fact, you could just pause the video, right? You could, that's another choice, is you could watch the video and pause it and see that we have, what is it? I have www.en/worksheet/419192304-971. But you could email me and say, Mr. Hall, can you just send me the website? So all you have to do is click on it and it would open up if that's something you're interested in. All right, so let's try to do this one. 240 people are taking science classes. There are 104 people studying chemistry, 132 people studying biology, and 68 of these are studying both. What is the probability that a person is studying chemistry given that they are studying biology? What tool should we use? I love a Venn diagram. What in here would suggest Venn diagram?
There's two subjects and then watch, but there's three people, one studying one, the other.
And there's something in the both, right? Since there's something in the both, we have an intersection. I think that is the telltale. This part right here should be telling you that we should use a Venn diagram because we have both. You could use a two-way frequency table, but I really think the Venn diagram is the better choice. It helps us wrap our heads around what is going on if we can see a visual. Humans are visual creatures. Some animals, they rely on their other senses, like dogs rely on their sense of smell more than they do their sight. They use their sight for sure, but we use our sense of smell as well. But with humans, our eyesight, we rely on our eyesight more than our other senses in general. So we are visual creatures. So it really helps to have a diagram that helps us wrap our heads around what's happening here. So it says here that we have, so where do I start with this? So we have two groups. One of them is chemistry. And we also have biology. And so where do I start?
Well, the question is, what's the probability? Oh, you fill it in. There's 104 people studying chemistry.
So 104 people in chemistry, so 104 goes here.
No, because there's 68 studying.
So it has to be this plus this is 104, right? So that can't be right. So what if we work backward? What if we work backward? Do you think that might be more helpful? Yeah, we know 68 are in both. So let's just put 68 in the middle. Now, if 68 is in the middle, does that help us figure out what goes here then? How? Brian, good job. We're going to subtract. We have all of this is 104. So we're going to take 104 and we're going to subtract the 68. That gives us 4, 5, 6, 6. I'm getting 36. Does that sound right to you? Does that give us 104 here? Yep, I agree with you. All right, now it also says that, bless you, 132 people are studying biology. So, yeah, 132 minus the 68. It gives us 4 and then 6, 64, 64. So does that give me 132 here? Yep. And then I'm curious to know if something is out here. Is it possible to have something out here? Yeah, so people, well, here it says 240 people are taking science. So my universal set is people taking science. All of this is people taking. Yeah, what science is not chemistry or biology? What about physics? Do you guys know what physics is? It's the science of what? Physics is the science of movement. It's studying movement. And in fact, it's really interesting that falling objects are quadratic. And that's a big idea that we're going to talk about this year. That's our next chapter, talking about quadratics. When you throw an object into the air, when I stand here and I throw an object in the air, it makes a parabola. This is quadratic. It's not linear. It's not exponential. It's a different function group that we're going to be talking about. And so physics is the study of what? Movement. It's just the study of movement. So is physics part of biology? What's biology? The study of what? Of life. It's the study of life. What's chemistry? Yeah, it's the study of chemicals. So we have other branches too. My sister got a PhD in geology. Do you guys know what geology is? What is it? The study of what? Yeah, it's the study of Earth. Yep. Like you're talking about rocks and rock formations and stuff like that. Yeah, the study of Earth specifically is geology. So what is the question? What is the probability that a person is studying chemistry given that they are studying biology? I already know they're studying biology. Well, we don't have an A. Oh, chemistry. So if it's given that they're studying biology, I already know that this is my universal set is now limited to just this group here, right? Because I know that it says here, given that they are studying biology. I already know that. So what's my equation? Number of ways it can happen out of the total number of outcomes. So close. I'll give you the first ones. I agree with 68 over. Problem with 68 over 64, you're going to get a number greater than 1. Probability can never be greater than 1. What's that? Louder. Probability of A because this is a conditional statement, it's given something. This is conditional. We're not looking at the entire population. The denominator has to change because it's a conditional statement. So this is what you said, right, Shelby? That was your first thing you said, and then you switched it. But you were actually really close here. There's something you're missing. Nope. These are not percentage. No, these are not probabilities, right? These are they are real numbers.
Yeah.
They're numbers of individuals. Why?
Oh.
Why? Why?
That's all biology.
That's all of biology. Yeah, okay. It's this value here over this value here. We already know biology. We don't actually have to count this up. What is it? Doesn't it tell us up here? That's 132. Is that biology? Yep, 132. Yep. So this is 68 over 132. 68. Oh, it looks like they simplified. Can we simplify this? Is that simplifiable? They're both even, so I know 2 goes into it. 2 goes, so that means we can cut both of them in half. 68 becomes 34. Half of 100 is 50. Half of 30 is 15. 50 plus 15 plus 1, 66. Does that sound right? They're both even still. So what? Okay, so once more, we're going to cut both of these in half. That gives us half of 30 is 15. Half of 4 is 2. 15 plus 2 is 17. Half of 66? 33. Is that a choice? Nice. There we go. Go. We got it. Ryan, how are you feeling? Is it still confusing? Yeah, it's okay. It just means you need more repetition. And in fact, honestly, what we're doing right now is actually more difficult than your test. But for those of you who are planning on maybe taking statistics, this is really great. This would give you a better idea of what the AP statistics class is on. I feel like I gave you everything you need to be able to figure these out, but they are a little bit more sophisticated than you would normally see. On the street, 10 houses have a cat. 8 houses have a dog. 3 houses have both, and 7 houses have neither. What tool comes to mind here? Why? It uses both. Yeah, we have an intersection. Because we have an intersection, it would be really helpful to have a Venn diagram so that we can wrap our heads around these. What are my different groups? What are they?
Cats, dogs.
Okay. Is neither, and neither is a group, but we don't need a circle for it, right? So the first one is, and they told us that cats is C, so I'll just write a C right here. Dogs is D, I'll write a D right there. And so where do I start? Yeah, let's do both. Let's not worry about this here because I don't know whether what 5 here or 6 or 4. I don't know how to divide up the 10. So let's start with both first. Let's start with both. 3 houses have both. So I'll write a 3 right here. So what has to go here?
7.
Yeah, we have 10 cats. So this 10 houses have cats. So this has to be 7. So we have 7 plus 3, which is 10. Okay, so you're going to, so all dogs, we have 8 houses have dogs. And so all of this has to be 8. And we already have 3. So what has to go here? 5. 5 has to go there. So I'm going to write a 5 right here. Now it also tells me that 7 houses have neither. Where does that go? On the outside right here. It's not part of the cats family. It's not part of the dogs family. It is neither. All right, let's see if we can answer the question. What does the question say? Find the total number of houses on the street. Hence, find the probability that a house chosen at random has both a cat and a dog. Huh? Find the total number of houses on the street. How many houses are there on the street? How'd you get it?
You add 7, 7, 3.
We take 7, 3, 5, 7. You just had it in a different order. That's okay. Because of the community property, it's still right. We just add all these up. I add this, plus this, plus this, plus this. And that gives us all of the different houses on the street. And 7 plus 7 is 14. And then plus the 5 gives us 19. And then the 3, 20, 21, 22. Is it 22? Is that right? Did I count it wrong or did you count it wrong? Now, one more time. Let's just make sure. So 7 plus 7 gives us 14. 14 plus 5 is 19. 19 plus 3 more, that would give us 20, 21, 22. Yeah, I'm getting 22. All right, so I'm getting 22. So now it says, find the probability that a house chosen at random has both a cat and a dog. I want to know the probability that a randomly chosen house has a cat and a dog?
Would you just be able to do like whatever percentage? 322?
That is the answer. Number of ways it can happen. How many different ways can it happen that a house has a cat and a dog? 3. Out of the total number of outcomes? 22. So throw that in our calculator. 3 divided by 22 gives us, I'm getting approximately 1, so 0.13636, which would be this one here. There we go.